Every great civilization in history has a foundation built not only on dreams and ideas, but on calculations, precise drawings, and ingenious solutions. These foundations were laid by engineers. From the ancient pyramids of Giza to the Mars rovers exploring distant planets, the silent but powerful force driving human progress has always been the minds of engineers. They do not seek the spotlight. Their work often remains invisible, yet our world runs because of them. In this journey, we will explore who engineers truly are, the diverse fields they work in, their daily impact on our lives, and how they continue to shape our future. This is not just a profession. It is a mission to solve, to build, and to improve. Engineering is the practical application of scientific principles to design, build, and maintain structures, machines, devices, systems, and processes. At its core, engineering is about solving problems. Engineers are both creators and caretakers. They innovate new technology and ensure existing systems function properly. The word engineer comes from the Latin word ingenium, meaning talent or cleverness. Historically, engineering began with military inventions, catapults, siege towers, and evolved into civil and mechanical applications. Today, engineering is a multidisciplinary field with applications in every industry: health, environment, transportation, energy, space, communication, and more. Engineering differs from pure science in that scientists explore nature to understand how it works, while engineers use that knowledge to create tools that benefit humanity. Key responsibilities of engineers: analyze problems and identify solutions. Design and test systems or products. Ensure safety, efficiency, and cost-effectiveness. Adapt technologies for human needs. Imagine a world with no bridges to cross rivers, no airplanes to connect continents, no electricity, no clean drinking water, and no internet. That's a world without engineers. The role of engineers in society. Infrastructure. Engineers build the roads we drive on, the railways, tunnels, dams, and skyscrapers that define modern cities. Technology. From smartphones to satellites, engineers design the hardware and software that make global communication possible. Healthcare. Biomedical and chemical engineers design life-saving equipment, prosthetics, and medications. Energy. Electrical and environmental engineers work on clean energy solutions and power grids that light up our world. Safety. Engineers develop safer cars, earthquake-resistant buildings, and disaster management systems. Economic growth. By increasing productivity, engineers help industries become more efficient and competitive. Without engineers, innovation would stall, economies would weaken, and society would regress. They are essential for sustainable development and improving the quality of life. Engineering is not one single field, but a vast universe of disciplines. Let's explore them in detail. Civil engineering is one of the oldest branches of engineering. It deals with the design, construction, and maintenance of the built environment. Key areas include structural engineering, which covers bridges, towers, and buildings. Transportation engineering, responsible for roads, railways, and airports. Hydraulic engineering, focusing on dams and canals. Environmental engineering, which manages wastewater treatment. And geotechnical engineering, dealing with soil and foundations. Examples of remarkable civil engineering feats are the Hoover Dam in the USA, the Millau Viaduct in France, and the Burj Khalifa in Dubai. Civil engineers make human settlements possible, resilient, and efficient. Their work ensures safety, accessibility, and sustainability.
Mechanical engineering is all about machines, mechanical systems, and energy. Mechanical engineers use the principles of force, motion, and thermodynamics to innovate. They work in automotive engineering, robotics, HVAC systems, and manufacturing. Think robotic arms in factories, jet engines, and wind turbines. These engineers are vital to powering industries, transportation, and driving innovation forward.
Electrical engineers work on electricity,
electronics, and electromagnetism. Their work enables modern communication, power distribution, and automation. Key areas include power systems, such as generators and transformers, telecommunications including 5G and satellites, control systems, and microelectronics like chips and sensors. Examples include electric power grids, mobile networks, and circuit boards in every electronic device. Electrical engineering powers the digital age, enabling rapid communication and connectivity. Software and computer engineering focuses on designing, developing, and maintaining software systems. Key areas include web and app development, cybersecurity, artificial intelligence, and cloud computing. Examples are operating systems like Windows and Linux, apps like Google Maps and WhatsApp, and machine learning algorithms. Software engineers shape the virtual world, building the platforms and digital systems we use daily. Chemical engineers work with processes that convert raw materials into useful products. Key areas include the petrochemical industry, food and beverage production, pharmaceuticals, and environmental control. Examples include oil refineries, vaccine production lines, and water purification. Chemical engineers make modern materials and medicines accessible and safe. Industrial engineers optimize complex systems, processes, and organizations. Key areas include supply chain management, quality control, and lean manufacturing. Examples include optimizing factory layouts and reducing waste in production lines. They ensure maximum efficiency with minimum waste, improving productivity and sustainability. Aerospace engineers design aircraft, spacecraft, and related systems. Key areas include aerodynamics, propulsion, and avionics. Examples include SpaceX, Falcon rockets, Boeing airplanes, and satellite technology. Aerospace engineers push the boundaries of human exploration and air travel. Architectural engineering blends structural engineering with building design. Key areas include building systems such as electrical and HVAC and sustainable architecture. Examples include smart buildings and energy-efficient lighting and ventilation. They create buildings that are safe, functional, and eco-friendly. Environmental engineers address environmental challenges through engineering solutions. Key areas include pollution control, renewable energy, and waste management. Examples include solar farms and air purification systems. They protect ecosystems and ensure a healthier planet. The future of engineering. Engineering continues to evolve. Biomedical engineering is advancing prosthetics and brain-computer interfaces. AI and machine learning are transforming industries. Quantum engineering is exploring new dimensions of computing. Sustainable engineering is tackling climate change. Tomorrow's engineers will work on problems we haven't even imagined yet.
Engineers are problem solvers, innovators, and builders of civilization. As the world faces climate change, health crises, overpopulation, and technological disruption, engineers will lead the way. Every heartbeat in a pacemaker, every light in a city skyline, every rocket that leaves the Earth carries the legacy of an engineer. They may not be in the headlines, but they are the heartbeat of progress. To every aspiring engineer, you are not just building machines or bridges. You are building the future.